So, welcome back to the series named In the Search of Shooting a Cat, in which we talk about something special right now. Last video, we talk about the Bohr's atom. How a Bohr atom get a structure, like an atom get a structure in the quantum mechanics or in a real world, okay? And now, I am talking about something special element named as the God's dice. For about this element, the Einstein also said that God does not play dice with the universe. That's a very big line, okay? So, today's video start with this topic. I hope I tell the story like in a story form so you can easily understand what I need to tell. Okay, so I hope you enjoy the story and also understand about this element. So, start the story. What if the universe is not as ordinary as we believe? What if beneath the surface of reality, chaos resides supreme? This is the unsettling question that haunted some of the greatest minds in the history. A battle was burning in the realm of physics, where Einstein himself stood against the rising tide of the quantum mechanics. Once upon a time, Einstein was also against to the quantum mechanics. He famously declared, God does not play with the dice, the universe, okay? Sorry for misspell. God does not play dice with the universe. That's a very big line. The air crackled with anticipation. The world's most brilliant physicists had gathered, their minds weighted down by the mysteries of the quantum world. Wa- On one side, Albert Einstein, the father of relativity, a man who believed in ordinary, predictable universe governed by immutable laws. On the other hand, Niels Bohr, the champion of quantum mechanics, a theory that suggested randomness was woven into the very fabric of reality. God does not play the dice with the universe. There must be a hidden variable, something we are missing. The moon is there whether we look at or it not. Okay? Einstein stopped telling God what to do. The evidence is clear. Quantum mechanics is not bound by our classical intuitions. Reality at the small scale is uncertain. Particle does not have the finite positions or speed until we observe them. Or we also have a we are telling you that we cannot measure the speed and the position of any particle at a quantum level at the same time because it's moving continuously. Okay, so let's back to work. Okay, and so begin one of the most thrilling intellectual battle of the 20th century, the heart of the conflict. Listen to me. Whether reality existed independently of observation, or if, as quantum mechanics suggested, the act of measurement itself shaped reality. Enter Erwin Schrödinger. Troubled by quantum mechanics implications, he devised a thought experiment of expose its audioability. A cat sealed inside a box. I talk about also this experiment in the last video. Its fate linked to a decaying radioactive atom. If quantum mechanics was correct, the cat would neither die or alive until we observed. A paradox, a challenge to a very nation of reality. Schrödinger. Now, it's an argument I can work with, surely. Reality must exist whether we observe it or not. According to Schrödinger, from the starting, according to quantum mechanics from starting, reality is that what we observe, not what is like doing, like going on behind our neck, okay, behind our head. It's what we observe. That's the quantum mechanics, okay? No Einstein. Quantum mechanics does not allow assert certainty. The wave function collapses only upon observation. Until then, reality exists is probabilities. It is not an illusion. It's a simple different form what we once believed. Okay. Einstein was not really done fighting, okay, at this moment. Along with his colleagues, he devised a scenario even more perplexing than Schrödinger's cat. What if two particles were entangled, connected in a such way that measuring one intentionally affected the other, no matter the distances. Okay, so in this, the two particles affecting each other, no matter how much the differences means a galaxy to another galaxy. Listen to me carefully. Distance doesn't matter. They're affecting each other. If one affect, then it's automatically affect the other atom of the same element. Okay, it is separate each other at a different. Okay, so if true, this phenomenon, which Einstein called spooky action at a distance, defined the law of classical physics. Yeah. Okay. If Einstein wishes to challenge quantum mechanics, he must to do more than this. Entanglement is not an impossibility. It's a fundamental part of reality. Time wound time wound proof Bohr's right. In 1964, John Bell formulated an inequality that could test whether hidden variables existed. Decades later, experiment confirmed it. There, there were no hidden wars variables. Quantum mechanics was correct. The universe did play dice. Okay, so the story begins here. Today, we harness the very principles Einstein fought against: quantum computers, television pronotation experiments, and encryption techniques all rely on the bizarre truth of quantum mechanics. The debate that once raged in the hell of the academia now fuels the future of technology. Or was he? Perhaps reality is even stranger than we are imagining. Perhaps, in ways we are yet to understand, the universe still hoods onto its deepest secrets, and maybe, just maybe, God's play with dice. After all, so that's about all the God dice, about the element, about the experiments he shows. Einstein's is startingly in the starting, the Einstein is against to the quantum mechanics because if we go deeper to the quantum mechanics, we see that the classical mechanics rules are break out and breaking by the laws of quantum mechanics and the by behavior of the quantum mechanics. So that about the today's topic. We will meet in the next video. I hope you enjoy.